Today we will discuss some projects. Okay, data structure I hope is there for you now. Maybe in the next semester. Yes. Yeah. Data structures. As we have discussed while we were, learning the programming language, there are two important things that we have to know before the start of any programming language. One is the data types, and another is the operators we have said, right? The data type is nothing but the collection of objects and the set of operations performed over them, right? Data types are classified into built-in type, user-defined type, derived type, kind. Fine, like built-in such as int, cat, float, long, double. And you have user-defined such as structure, union, enumerated, Boolean, class kind of thing, right? And then derived types such as arrays and pointers. So these are all what we have discussed, of course, as part of C programming as well. And then before going to write any programming language, you need to know the operators, right? What kind of operators that this particular programming language is offering for us. So we have seen the kind of operator that the C++ is offering is same as that of the what C was offering. All arithmetic operators are addition, subtraction, multiplication, division, and shortcut of the same. And then relation operator equal to them, less than, equal, less than, equal, not equal, double equal, single equal, which is nothing but assignment operator. Then we have seen, the logical operators such as logical and or not, kind of thing. And then bitwise operators like bitwise and or shift left, shift right, exclusive or kind of thing. And then ternary operators. Basically, operators can be classified into three kind with respect to the kind of operands needed for the operations, right? So if only one operand is required, we say it is a unary operator. If two operands are required, we say it is a binary operator. If three operands required, then we say it is a ternary operator. So most of the operator comes under the binary category, right? Arithmetic, logical, relational, bitwise, all this comes under binary. But then in addition to that, you have some unary operators like increment, plus plus, decrement like minus minus, pre post kind of thing, right? You have size of operator, and probably unary minus, right? These are some of the unary operators. Then coming to ternary operators, where three operands are required, for such as question mark, colon, right? So it is a very similar to that of your if-else kind. It's a replica of if-else. Right before the question mark, you have the condition. After the question mark, one statement upon the condition's truthness, and upon the condition's falseness, you have the colon after statement to be executed. So these are the different kind of operators, as of course C and C++ was providing for us, right? Unary, binary, ternary. Under unary, increment, decrement, size of minus, unary minus, and all we said. Under binary, like you have arithmetic, logical, bitwise, relational, and logical kind of thing. And then under ternary, we have seen it's a conditional or ternary, which is being used with the help of question mark, colon kind, right? So all these operators, but C was offering the same for C++. In addition to that, in C++, it was providing operator overloading concept. These all operators which are available as part of C, they are available in C++ as well, and they are meant to be performed over the built-in kind. But then, if you wanted to perform it over the user-defined kind in a very similar fashion, that how you perform it on built-in kind, for which, of course, you have operator overloading concept being provided in C++ with the help of operator keyword. That also we have seen in detail. Fine. So these are the two basic things that you probably see. And then, in addition to that, of course, data structures, right? Data structures is nothing but the data how is going to be organized on the machine. Is what said to be the data structure, right? Fine. So data structure is nothing but set of mechanisms, I can say, right? set of mechanisms to organize the logical and mathematical data over the system. Fine. We have different kind of data structures, like we have linear data structures, and non-linear kind. Okay. Under linear, you have stacks, queues, linked lists. Under non-linear, like you have trees, and graphs. Okay. So here, linear in the sense when the data is organized in a linear fashion, we say it is a linear data structure. If they are organized randomly, then we say it is non-linear kind of way. We have trees and graphs and all. This subject you are going to study in detail in next semester, right? Using C++, you are going to implement all these projects. But here, I just wanted to show you some of the projects here using the constructs that we have studied as part of our C++ subject, right? So I'll take one example of stack and which I wanted to demonstrate today. Fine, for you using the C++ concepts that we have learned so far. Is it clear to all of you? Stack, it is a very important data structure, and it's a part of your system memory nowadays, right? Because their applications are quite wide. Okay, the function execution, the mechanism of function, the implementation of the function, is going to be done with the help of a stack, and recursion can be implemented only using the stack. You have searching sorting techniques that you have studied, and you see BFS traversal, tree traversal, many of the algorithms, to implement, we need stack. And many of your gaming programs, all the gaming programs are implemented using stack. Stack is very much required, right? And if you look at the back button of your browser, right? Or in your mobile, you have a back button. That back button is implemented with the help of stack, data structure. Their applications are quite wide, and you have expressions, mathematical expressions. You give in fixed form, like you give A plus B into C, but then it is going to be converted either into prefix or postfix form, and then that will be evaluated. So to convert it into either prefix or postfix form and evaluate, you need a stack, right? So regularly for any program to execute, stack is very much required. That's the reason why you can see in system memory. If you look at the system memory, after stored program concept came into being from one human architecture kind, where you find the memory of this system. System memory, when I say it is the primary memory or the preliminary memory, or you call it as RAM as well sometimes, right? So over which the program which is in execution will be available. So generally this RAM is divided into three parts, right? One part it stores the program instructions. Another part stores the data operands, and then another part, the third part, is available for stack operations, right? So if you look at now the memory available of any computer, right? So you have minimum of these three parts. First one is program instructions, right? Second one is data or operands. Okay. So you store operands or data, and then you store and you have some part of the memory left for stack operations to carry out the stack operations, right? So when you are logging in or when you are trying to submit your request to the operating system, immediately it will allocate some part for your stack operation from this stack memory for your program, for your task, right? And your stack operations are going to be carried out within that particular memory which is reserved for you. Sometimes when you are trying to perform more stack operations, you may get one kind of exception called stack overflow. Stack overflow is one of the exceptions. As I told you, exceptions are going to be raised during the execution. Stack overflow is one of the exception, right? Which is of course can be handled by using proper handling mechanism like try catch throw that we have seen in C++, right? But this is a system thrown. If it is, then the system must have to take care of the same. So operating system will take care of the same, right? Fine. So coming to stack, what exactly stack is? If you look at it is based on last in first out concept, right? So it's a mechanism. Stack is a data structure, linear data structure, I can say. It is based on last in first out. What do you mean by last in first out? The element which is inserted lastly will come out firstly. It means the first element will come out last. LIFO or philo, you can say. Yes or no? LIFO, last in first out, or you can say first in last out, philo, right? So stack is a concept based on last in first out. It means the element which is inserted lastly will come out firstly. For example, if you take a stack of this kind, okay, let us say you have stack of if I can have I can implement it using either arrays or linked list, right? So if I'm implementing it using, let us say, array, fine, and I have array of size, let us say 5. Okay, so the index value you start with 0, right? 1, 2, 3, and 4. So with the indices starting with 0 till up to 4, you can insert about 5 elements. You can insert, right? So the element space which is available, this is not there for you, right? Only till 5, right? So here, how do you insert the element over the stack is using the push operation. The element insertion over the stack, we call it as push operation. And if you are trying to delete an element, we say it is a pop operation. So how does the push mechanism is going to take place is, you insert an element. There is a top variable basically which is initially grounded in the sense that its value equal to -1. Okay, its value equal to -1. So what you do here in the mechanism under push, you increment top first, right? You increment top and you insert the element over the stack. If you let us say this stack is being pointed through S, then S of top, right, equal to EL, right? So this is the mechanism behind push operation. So if I have to, let us say, insert 10, so 10 is going to be inserted. Before that, this is the mechanism, right? First you have to increment top. Top is initially -1. -1 when incremented, you get 0. So top value becomes 0 now. So the value 10, which is going to be inserted over the stack, that is S of top equal to EL, you're saying. So S of top in the sense top value will be 0. So S of top means S of 0, right? S of 0, the value is going to be inserted, right? Now let us say you want to insert one more element, 20. The same kind of mechanism is going to be repeated, right? Increment top, then top points to 1 here, then 20 is going to be inserted. If you want to insert, let us say 30, then the same mechanism is going to be repeated. Then what happens? Top is when incremented will be 2. Then the value which is going to be inserted 30 will be at the index 2. Like that you insert, right? 40, 50 you have inserted. So how long you can insert? You can insert only 5 elements, right? Once it reaches, once the top value reaches 4, right? You can see top after being incremented, the element is inserted over the stack where top is pointing. So top is always pointing to the topmost element. Topmost in the sense the currently inserted element, lastly inserted element rather, right? So now what is the element which is inserted over it? 50, which is being pointed by top. And what is the top value here? It's going to be 4 here. You can see the top value is 4. Yes or no? Top value is 4 here, right? Now, when top value is 4, stack is full, you can say, right? This is called condition. This is nothing but an exception here, right? So you have to check this exception before you insert, right? Stack overflow. Fine. Stack overflow. When does stack overflow happens? When top value is equal to 4. So when top is 4, you cannot further insert, right? So this is an exception. So I can implement this using the exception mechanism, right? And this is the mechanism to insert over the element, stack. And now when I want to delete an element, I'll be calling the pop function. Pop is a function to delete an element. How does you're going to pop the element? Element being pointed by top, right? Element being pointed by top is going to be deleted, right? So what is the element which is being pointed by top is nothing but 50. So 50 is deleted. So 50 is deleted when you call pop function. And then top should be decremented. Top will be now pointing to the next element, right? So it means top value becomes what? 3 now. Top value becomes 3. Yes, sir? So again, when you are calling pop, the same mechanism is going to be repeated. What is a mechanism which is going to be repeated? The element being pointed by top is going to be deleted. That is 40, right? 40 is deleted. And then top is decremented. When top is decremented, top becomes what? Top becomes 2. So it means top is pointing to this element, that is 30. Again, when you call the pop function, what happens? It's going to delete now 30. And what will be the top value? It will be decremented to 1 now, right? So it's going to be 1 here, right? Fine. After 30. So like that. Again, when you call, what happens? It's going to delete 20, which is being pointed by top, it's nothing but 20. And then what happens? Top is decremented. When top decremented, top gets 0 here, right? Top is pointing here. Again, when you call pop function, there is further element, so that is 20, which is going to be deleted. And when the last element, which is nothing but been deleted, what do you get here? You get top value to be decremented, and that will be -1. Again, it goes back to rounded rather, right? So you can see here, the element which we have inserted is coming out, in a reverse fashion. I have inserted 10, 20, 30, 40, 50. But when I am deleting, what am I getting? I am getting 50, 40, 30, 20, and 10. It means the element which is inserted lastly, which is nothing but 50, which is coming out first, right? So this is the mechanism behind stack. How we are implementing it with the help of this push and pop. I hope this is clear to all of you. So we can demonstrate the same using the online compiler, right? So can you see my screen here?
Yes, sir.
So here I wrote one function. I wrote here 2 classes. First of all, overflow, underflow. I'll increase the size. It is large only. Anyway, so is it visible to all of you?
Yes, sir.
Yeah. So you can see I am using 2 exception classes: overflow, underflow. Class overflow, class underflow. Just opened and closed it. I didn't write any function here. If you want, as I said, you can write some function that can be rather invoked. But inside catch itself, I'm displaying something, so I'm not having any function here. So now you can see there is a class, stack class. This is a stack ADT. So in order to implement stack, what do I need? I need a array, right? I'm taking an array of 5 elements. S of 5 is my array. I'm using templates here. What is the advantage of having templates to be used? I can implement the stack for any data type. I can implement it for integer, character, float, long, double, or if I have any class kind like student records, if I have to implement, or if I have to implement it on employees kind, or if I have to implement on department kind of thing, bank class, I can implement accounts of bank and all such kind of things. I can probably do that. Right, having the template is nothing but a generic data type which will help you to implement the same kind of operation on different data type without having to write that entire code for that respective data type. Okay, so I'm using template. How do you use template? Basically, you have a template keyword, template space, within the tags you say class the template type, right? I'm using template type is T here. You can see there is a class stack in which this is my stack class in which I am taking array as of template kind. This array can hold the template kind of elements. It means generic element. It can be implemented for integer, character, float, long, double, and all based on the kind of data type that you pass during the implementation. And you have a variable here ELE in which I probably take the element to be inserted or when deleted to hold and also it should also be of T kind. So I'm taking it of T kind. Then I have I and T top variables. Top is basically being here required to perform all push and pop mechanisms. So we are taking top here. And then you can see there is a constructor stack. This is a constructor. Yes or no? So in constructor, I am initializing top. Top should be grounded. Top equal to -1 here initially. Then I have a push function. Push function is taking T type of element. Nothing but the element to be inserted over the stack. And the pop is going to return the element which is being pop from the stack, and display is going to display the elements, current elements which are available in the particular stack. This is my stack ADT, and now I am defining the code of these functions push, pop, and display outside the class. When you define the code outside the class, how do you bind it with the help of scope resolution operator? That is double colon. Yes or no? So here, since the functions are belonging to the class template. So when you define the source code for this particular function, they should be treated as function templates. So it means that you have to consider while writing the source code of the functions outside the class as a function template, for which you need to write the template tag every time, right? I can see you can see here template tag every time, template class which is to be repeated every time for every member function of the class template when being written outside the class, right? And you can see here every time when you are writing the class name is stack. So stack should be followed by the template type here. You can see within the tags I have mentioned the template type, right? So this is what we have discussed, of course, while discussing the templates and all. So I am using here template, because of which I am writing the function source code outside the class as a function template. So I wrote first the template entire template statement, then the template type has to be followed by the class name, right? Every time I'm writing. Now inside this, I'm having the mechanism. You can see here, when I'm inserting, how do I insert? This is the mechanism to insert. That is, I have to increment top. Initially, top is -1, right? I have to increment. Pre-increment, I have to use. So within the brackets, if you have pre-increment, the expression will be evaluated first, and then the assignment statement will take place here. So ++ top will be first executed. ++ top when happens, what happens? Top was -1, so it becomes 0 first. And then at 0, this element which you have passed, this x which I am passing probably from the main function, that I am taking it in ELE. ELE is the local variable of the class, right? So from ELE, I am transferring it into the stack, right? You can see the S is the stack. Stack is implemented here using array. So S of ++ top and SA, initially when top was -1, it was 0. So S of 0, at S of 0, ELE was placed, right? So this is the mechanism. I hope the mechanism is clear. But then you need to add the exception. What is the exception? When you keep on inserting the elements, how long you can insert? As I have taken the array size as 5, right? I can have only till index value 4, right? If when I reach the index value 4, that is when top reaches 4, I should throw an exception. What is the exception which I have to throw? That is overflow, right? Throw overflow, I said. So when this condition reaches, what happens? It creates a constructor of overflow, and then it will be thrown from where the control comes to the catch block of that overflow, right? Exception. So inside that, I am writing stack is overflow, which is going to be displayed, right? So that it stop inserting the elements over the stack, because this statement does not get executed, right? When say the control will be transferred from here to immediately catch block, and catch block will display that stack is overflow, right? So similarly, I'm having a pop function mechanism which I have discussed. When you are deleting an element, you'll be deleting an element being pointed by top. So being pointed by top, S of top. See, when you have post decrement, what happens? First, the element will be taken, and the decrement will take place next, right? It means S of top will be taken into ELE first, right? So let us say, for example, if you have inserted all the elements, seal up to 4, then top value must have been 4. Then S of 4 will be taken into ELI. Then top will be decremented. When top get decremented, top value will be 3. For the next operation, top value will be 3, of course, rather, right? So this is going to happen, right? This is the mechanism. You will be deleting the element being pointed by top, and then you are decrementing top, right? Fine. So the element being deleted is being held in ELE, and the same is going to be returned from this particular function, because you have the return type T. T is of which kind, whichever the data type for which you are implementing the stack is of that kind, right? So since you are writing when the functions of the class are outside of the class, you are saying it is function template. So you are writing the template statement, then wherever the class you have, followed by the stack template type. Then this is the mechanism. This is the mechanism, right? So the top pointed element will be taken into ELE, which is going to be written, and then of course top is going to be get decremented, right? So after immediately s of top is transferred into ELE, top gets decremented here, right? So now you can see when you are deleting the element, let us say there are 5 elements you have inserted and you have called this top element for 5 times. So every time when the element is deleted, then top get decremented, right? To delete the next element, because when the element which has been deleted, top of course points to the next available as its top element, right? Because the one which is removed should be avoided from considering, so the top get decremented and will point to the next top elements. So that way, when top gets decremented and all the elements are get deleted, what happens? Top gets 0. When top reaches 0, of course there is an element that we can delete, but after the top value when pointed with 0, the last element get deleted, top gets what? Decremented, and you get its value as -1 rather, right? -1 is less than 0, right? So it is an underflow. Underflow in the sense there are no elements, right? Stack is underflow. There are no elements, so you can't further delete the elements from the stack. So if top is less than 0, this is the exception which is to be handled. So I am having an underflow class before itself. You may have seen. So when top reaches -1, that is top less than 0 is going to be true. Then what happens? It creates underflow constructor and then throws the same. So from here the control comes to the cache block. And in the cache block, you are saying stack is underflow and you are assigning ELE as -1. Since you are returning ELE, ELE must have to be equipped with some value. Since this statement is not going to be executed, then some value must be there in ELE. So when you are deleting element, then the element which is deleted is going to be held in ELE. But then when there are no elements to be deleted and this condition is true, the control from here, it comes to the cache block. In the cache block, you can see that stack is underflow, you are saying, but you have to return ELE, for which in order to make the user known that nothing is available, I am saying -1. -1 in the sense nil, right? ELE equal to -1, I'm saying, right? So that -1 is going to be returned. So when you are calling this particular pop function and you are getting -1 in the sense that there are no elements, right? Stack is empty, the other way around, right? So this is how the mechanism of pop function is implemented. And you can see display. Whenever you are calling display, it has to display the elements from top till the last, right? Top to bottom, right? So I'm using a for function, first statement, I equal to top, I get I equal to 0, I minus s of I is set, right? So all the elements from top till bottom will be displayed. But again, when displaying, there is an exception that you have to check it. There are no elements, you cannot display rather, right? So how do you know that there are no elements when top is less than 0? When top is equal to -1, it means there are no elements in the stack. Right, this condition is going to be true. Then you have to create an underflow constructor and throw the same. Then you come to the cache block and you say that stack is underflow, no elements to display, right? So this is how 3 functions of this particular, stack is implemented. So this push and pop are going to help you to implement the last in first out concept, right? Now we will try to demonstrate the same here with the help of main function. In main function, you can see I am taking one object of this stack, right? So while I'm creating the stack is a template class, so I need to pass the data type for the template. So I'm passing here integer. So it means that T is going to be replaced with integer. It means that the stack array is going to be of what kind? Is a integer kind. So you are implementing on integer, right? So if you say here character, then of course for character you will be implementing it. So I'm saying stack integer object. I'm creating one stack integer object here. Then I'm trying to invoke this push and pop functions, continuously based on my desired number of times until I get exhausted. So for which I'm taking one, do while statement. So with the help of this do while statement, what is that you are trying to say? If user is willing to perform the operation for the next time. We are giving the option for the users with the help of a switch case. He can go with either of this operation. We have push operation, yes or no. We have pop operation, we have display operation, and then we have exit. If he get exhausted, he wants to come out of it, then he can go for exit function rather, right? So this particular options are available for the user. In order to make the user to know that what kind of options are there, I am displaying one menu. So under this menu, I am showing the code for which the different kind of operations are going to be carried out are mentioned here. 1 for push, 2 for pop, 3 for display, 4 for exit, right? So here I am accepting this code in the code variable. Code is an integer kind which I have taken. And when I am trying to insert in the integer data over the stack, I am taking it in a variable called data here, right? So, and then I have a character variable called ch in order to take the input from the user in order to know whether he wants to continue the operation or not, right? If he wants to continue, he has to press yes, right? So if it is small y or capital Y, it will allow you to go for the next iteration. So this is a do while. In do while, what happens? You will be allowed for the first time. After the execution is done, you will be you will be asked to enter the value to whether to continue or not. So if you are giving that value, then and the value is satisfied with the condition, then here you will be allowed for the next iteration. So that way it's going to be repeated. How long? It's going to be repeated infinitely until you say no. Until you say no. If you say yes, it will be in a loop time. When you want to get exhausted, you can get exhausted from the switch as well by saying 4. When you say 4, also you get exhausted from the execution rather, right? So this is how the main function is developed. In order to repeatedly execute and allow the user to go for the different kind of options over the single execution, and to demonstrate and see that how the overflow underflow conditions are working and how the insertion and deletions are taking place, whether it is showing you last in first out kind of a concept or not. I hope this is clear to all of you. Now we'll try to demonstrate the same. Okay, is it clear? The code is clear to all of you? Yes. I'm here executing the same. You can see the menu is displayed. Fine. Under the menu, we have push, 1 for push, 2 for pop, 3 for display, 4 for exit. We said enter your choice. If I say 1, it should allow me to go for push function, right? So in order to push, what data you want to push, it is asking. So let us say I am trying to insert 10 here, right? So 10 is pushed onto the stack. If you want to continue, it's asking whether to continue or not. If I say yes, then it will allow me to go for next execution. So again, the menu will be given for me because this entire code is available in do while, and the entire code is going to be repeated in do while. How long? As long as you want to continue this particular execution, right? Over the same execution, you are trying to implement multiple operations with various choices rather, right? So if I want to again insert further element, I say enter your choice. 1 for push, so I said 1. Now let us say I am inserting 20. Now 20 is inserted. I want to continue. Let us say I say yes. Then let us say I want to display what elements have been so far inserted over the stack, and I can see with the help of you can see here enter the choice. When I said 3, the elements which I have inserted are 10 and 20. 10 I have inserted first, and 20 I have inserted next. From top to bottom I am showing. So top is 20, you can see, right? And next to it is 20, right? So 20 and 10, both of the elements are available so far now. That way I can probably go on inserting the elements over the same. I can insert how many elements further? I can insert 3 more elements. So I say 1 again, yes, here I say. If I say yes, it will again give me the menu and enter your choice. It is asking. If I say 1 here, I can further insert another element. I say, let us say 30 to be inserted. So we have elements now 10, 20, 30 inserted. And let us say again, yes, if I say, then it will allow me to again, I am inserting 1 more element, that is 40. Yes, I am saying, and I am inserting another element, 50. So now we can probably see what are the elements available on my stack with the help of the display function. So I have 3 choice to display. So you can see 40, 30, 20, 10. These are the elements which are so far inserted. I want to insert one more element. Let us say 50. I'll go for a push function. I am inserting 50. So how many elements now so far inserted? There are 5 elements available. If I want to see all those 5 elements, I can see here 50, 40, 30, 20, 10, right? Now I want to pop the elements. Whether you want to go for, yes, I want to go for, and then further perform the pop operations now this time. So I have to take the choice as 2. When I take the choice as 2, it will delete one element. What element you can see is deleted here? What element? 50 is deleted, right? What is the element which we have inserted? Firstly, 10 we have inserted first, 20, 30, 40, 50. This is how the order which we have, inserted. But then when I am trying to delete, which element is coming out? You can see 50. 50 in the sense the element which is lastly inserted, right? The element which is lastly inserted is coming out first. So this is what exactly the mechanism which we wanted to demonstrate with the help of stack. That is last in, first out, right? You can see now what are the elements left out in the stack. If you want to see what are the elements left out in the stack, I can go for display function. It will show me 40, 30, 20, 10 are available, right? 50 is deleted, right? I want to go for further operation. I want to delete furthermore. I say 2. Then I want to see again when I am next time saying pop what element is deleted. 40. 40 is the topmost element in the existing of this stack rather, right? So always the topmost element is going to be deleted rather, right? So you can see enter again choice. If I'm asked to do that, I am here performing again, let us say further pop operation. When I say further pop operation, you can see 30 is deleted. Yes. Now what are the elements left out in the stack? Only 20 and 10. If you want to see with the help of display, you can probably see what are the elements are left out. 20 and 10 you can see, yes. What are the stack elements left out on the stack now? 20 and 10, right? So I want to now, let us say, delete further. I say 2 again. 2 is the choice for deletion. So now what element is deleted? 20 is deleted. So after 20 is deleted, what is left out? Only 10. You can see what is left out with the help of 3 choice. You can see there is only 10. I want to further perform, I say S, and now I want to delete that element as well, whatever is left out. So when I say that what will be deleted, 10 is deleted. Now stack is empty, right? I want to see the elements available in the stack. If I go with 3, I can probably see what are the elements available in the stack. There are no elements. Stack is underflow, no element is to display, no element to display. But I want to further delete. I want to further delete. Then it becomes what? It becomes an exception, right? So when I am calling pop function here by giving my choice as 2, then what kind of condition or exception I will be resulting with? Underflow. Yes or no? You can see stack is underflow. There are no elements to display, so stack is underflow. Yes. So this is how exactly I have implemented. Now you can see with the help of exceptions. I have used good number of concepts here to implement this stack project. Stack ADT. You can see I have used templates. I have used exception handling here. I have used switch case here. I have used do while here. Exit function. You can see how switch case works. You have already studied in C, right? It basically helps you to perform one at a time over a set of operations rather, right? Here you have 1, 2, 3, 4 choices you have, right? In 1 you are performing push operation. In 2 you are performing pop operation. In 3 you are performing what? Display, right? You can see in case 1 when you are trying to perform push operation, you first accepting the data from the user with the help of this particular statement, right? Enter the element to push over the stack. With the help of data, you are accepting some data from the stack user, and the same is being pushed over the stack with the help of push function, push of data. So then you have to have break. Every case must be terminated with a break statement, rather, right? And similarly, when you are calling pop function, you can see you just simply call the pop function with the help of the object. SIOB is the object of the stack integer, SIOB.p pop, and you say it's going to return some value. If the element is deleted, then the data must be there. Otherwise, it will be -1. So if it is not equal to -1, only then I am displaying, because only then the data is deleted, right? So that's the reason why I have added one condition here. If data is not equal to -1, then only I am allowing this particular statement followed by if to be executed. So wherein we are saying, we are showing the data which has been available is deleted from the stack, right? If it is -1, then this condition is false, so this statement will not be executed. You will directly break the switch, right? And in 3, you can see I'm calling the display function. Since it is a member of the, again, the same stack, class, I'll be invoking with the help of its object SIOB here, then followed by break statement, right? And 1, 2, 3, if you are not taking as your choice, then you can go for exit. Fine. 4, if you choose, that terminates the program at all, right? The program itself, right? If none of the choices taken, then you go to the default, where we are guiding the user to go through the menu rather, right? So this is the menu. You please go through the menu, based on which you can probably take a choice and then execute the same you are saying, right? So when you want to come out, you just say no here, right? I said no here, okay? And then when I say no, I'll come out of it. I'm coming back to my program, right? So this is entire switch is available in do while. In do while, we have this menu to be displayed first, and we are accepting the choice with the help of code variable. The choice can be between 1, 2, 3, 4, based on which the respective case is going to be executed in order to perform push pop display or execute, right? And once it is done, you will be allowed for the next time, right? Whether you want to continue. If you want to continue, you can give the choice as yes. Then you will be allowed for next time by, again, with the menu get displayed for you to take a choice out of it, and then you can go for the respective case to execute the same. This way is going to be repeated. How long? Until you get exhausted. Either you can come out of the program through 4 here when the code is asked. Otherwise, you can say no here, right? While the computer is asking for the next time to continue or not, right? So this is the main function from where we are trying to execute this entire data structure, that is stack, right? So stack, as I said, is a data structure which is used to organize the data in last in first out order, right? So the element which is inserted lastly will come out first. You can see back button of your what do you call computer, or you take the browser, or you take your mobile, is based on the stack concept. And you have all the gaming programs. You have the statuses, restored of the previous situation with the help of the stack, right? So recursion is the best example, right? Wherein you need to have the previous statuses to be available, which is being stored in the stack, and then it will be popped based on the order in which they are required in order to finish that respective expression to be evaluated as the order mentioned for the particular respective recursive function, right? And you can see infix to post conversion or evaluation of prefix post. A lot of applications, of course, right? And it's a searching, sorting program, lot of stuff. Of course, without stack, you can't run the program at all, as I said, right? Whenever you submit your request, whether it could be your program, it could be a simple Word file. In even Word file also, you have the statuses stored. When you say restore, it will give you the previous statuses. It's also based on stack itself, right? So you take up any application which you open it, right? For each of the application to run, you need some stack memory, which is going to be given by the operating system for you. Whenever you submit the request, and you are going to perform, and your operation stack operation will be performed within the particular memory which is allotted to you, rather, right? So this is what for today's class I wanted to discuss. I want all of you to please register your number by marking in the in the chat box, please. Is there any doubt here? You can probably ask if you have any doubts. So most of the data structure program, probably when you see it in the next semester, like queue implementation, linked list, trees, and all, right, where you find stack applications is very much necessitated, right? So here I wanted to give you an assignment. Similar to stack, we have a data structure called queue, right? I will explain you what is queue, and I want you to implement a program for this. Queue is based on, it is a linear data structure, of course. It is a linear data structure based on first in, first out, okay? First in, first out. What do you mean by first in, first out? For example, you have elements like this, okay? Let's say 0, 1, 2, 3, 4, okay? I have inserted 10, 20, 30, 40, 50, okay? There are two pointers called rear and front basically, okay? Rear is the rear end and front is the front end. So insertions are going to be performed from rear end and deletions are performed from front end, right? Rear insertions we call it as, and then front deletions. Okay, like how in stack both push and pop means the insertion and deletion both we perform through the top, but then here in queue we perform with different variables, right? Rear is used for insertion and the front is used for deletion. So I just directly give you the implementation of the same in a algorithmic fashion, which will help you to prepare a program for the same, right? Let us take a rear and front initially 0, okay? Both are 0 initially. Now we want to insert one element. So insertion function. How does insertion function works is, you will insert the element, 10 is inserted over the queue, let us say queue if you have an array, where rear is pointing, right? Where, and then you increment rear, okay? This post increment you can do that, right? Q of rear equal to Q of rear plus equal to EL in the sense that you are inserting the element that is 10 over the queue where rear is pointing, where rear is initially 0, so at rear, and then rear will be incremented. When rear is incremented, rear is at 1, okay? So similarly, you do that. The same statement is going to be repeated for insertion operators. So when you are trying to insert 20, where 20 is going to be inserted, the element inserted where rear is pointing, rear is now at 1, so this will be, and then rear is incremented, so rear will be at 2. Again, you want to insert 30, 30 will be inserted where rear is pointing and rear will be incremented, and 40 you want to insert, 40 will be inserted where rear is pointing and rear is incremented, and when you are inserting 50, 50 will be inserted where rear is pointing and rear is incremented. When rear is incremented, rear becomes 5, right? The index value 0, 1, 2, 3, 4, then it will become 5. So here, when rear reaches max, that is nothing but the size of the array, right? When rear equal to 5, you say it is an overflow. Yes or no? It is an overflow. Q is overflow. So the exception overflow, you will be checking it with the help of what? Then rear equal to. So before you insert, you will have to check for the overflow condition, right? Similarly, deletion. So how do you perform deletion here? When you're performing deletion here, okay, you delete the element with the help of front, as I said, right? So element being pointed by front is pointing initially at 0, right? So element being pointed by front is going to be deleted, and then front is incremented. This is what the mechanism is. It means the element which you are deleting is going to be deleted from front, right? Front plus I say, right? ELE equal to Q of front and then front plus you say, right? Got it. So here we said Q of rear plus equal to ELE. Here I am saying ELE equal to Q of front plus or Q of front and then front plus whatever it will be, right? So front pointed element is going to be deleted and then front is incremented. So that way it happens. Now you can see the element order in which the insertion and deletions took place. The insertion order is 10, 20, 30, 40, 50, and the deletion also 10, 20, 30, 40, 50. It means it is performing what? First in, first out concept. Yes or no? First in, first out concept is able to perform. So, and here what could be the underflow when basically all the elements get deleted, right? You can see the front is pointed to next, and when this is deleted, front becomes 5. So when rear and front are equal, right? When rear and front are equal, you can say underflow. So this is the exception which you are going to check for underflow, right? That way you have to write the program. I hope the concept is clear. You